Or wait a minute.
Look, we just did A's and B's like this. So let's use A's and B's.
So big,
What is the genotype of the parent?
Is this where you use the little dashes? You put like a big W with a little dash?
No, could it just be like big A?
Remember I told you that our parents are always homozygous.
Yeah, big A.
So that means, hold on now, that means that the parents are homozygous. That means you can't use a dash.
Right.
Okay.
Because that insinuates it can be heterozygous or homozygous.
Okay.
That's what the dash means. And that isn't this ratio. All these ratios are from homozygous parents. But here I'm asking you, what is the genotype from the Iowa and the Wisconsin?
What's the genotype?
Yeah.
Are you using A and B again? I'm sorry.
See, I did 9 purple to 7 white in A's and B's.
Okay, so it would be big A, big B, little A, little B, little B. So.
Now, I'm glad you're here. You're my perfect example.
No.
But you always speak. See, we know big A, big B is what?
Homozygous.
It's purple.
Okay.
Right?
Right.
So it can't be a parent. I'm crossing a white with a white. So it can't be big A, big B.
So what are we saying? Which?
What's the genotype of the parent?
Which gene determines purple?
You told me a big A and a big B gets purple.
Okay.
Big A, big B. Big A, big B. Big A, big B.
I guess one of them is big B, little B.
That's heterozygous.
Okay, well,
Let me give you a hint. Let me give you a hint.
Big B, little B.
It's down here. It's in the bottom of here. Because all of these are white.
Oh, so it would have to be
It
like,
would be big.
like what he did earlier.
Big A, little B, little B.
There it is.
Yeah, okay. Big A, little B, little B. And the next one will be little A, big B, big B. Okay.
And that will give me a big A, little A, and a big B, little B, F1.
Okay. That hurt my brain.
You see the logic in that. The genotypes are always going to be this. But how is inherited? Let me get you to answer one more. How could that become a 15 to 1? This is an easy one. How could all of that become a 15 to 1 ratio?
If you mix the child back with the parent? No.
What? How can
I can interpret all of this as 9 to 3, 3 to 1. I can interpret all of this as 9 to 7. How can I interpret this as a 15 to 1?
I don't know.
Make me work for my living. Let me give you an example. There's only one 1 on that board. That's like, see, all recessive. Now, what do the other 15 have that's different? Either got a big A or a big B. 15 to 1.
No.
So I can take this same genotype, depending on what the cross is, just like this 1 to 2 to 1. It could be a 3 to 1, and another situation could be a 1 to 2 to 1 for phenotype. It could be red to white, or it could be green, intermediate, or white, depending on what the cross.
No.
Did that go over your head?
Yeah.
Didn't I give you a cross with a red and a white before?
Yeah.
Then I gave you another cross with a green and a white. What was the F1 in this? Intermediate, because it had one green allele and one little allele that made it intermediate. Partial expression. Remember? But it's the same. Both of them I got 1 to 2 to 1 for the genotype. But this one turned out to be 3 reds to 1 white. This turned out to be green, intermediate, white. So the genotype can be interpreted all these ways. If you study that page on 90,
And if that would change.
it tells you what the genotypes are.
So all you would have to do would be change the original parent in order to get the 15 to 1 ratio.
I have to write the problem differently.
Okay.
Yeah. I I got one more thing.
Okay.
What time is it? Am I out of time? Because I can use up my time. What is it? What's my point? Y'all not going to tell me.
It's 10 till 4.
Okay, let me say this one thing. It will not take 10 minutes to say. I did. I said, did I tell you to go to the bathroom? Did I say that? You see these ratios here?
Yes.
All these are dihybrid crosses, right? Dihybrid crosses. There are two ways that dihybrid crosses can be made. I can do it like this, or they can be this way. Okay, I'm talking about this square here now. So in that little triangle I have, genes may be linked on the same chromosome, or they may be on different chromosomes. So you haven't had this yet, but I just want you to be aware of this. So linkage means the genes are on the same chromosome. Now, in the humans, we have 46 chromosomes, right? And we have 30,000 genes. So some genes are on the same chromosome, obviously. We don't have 30,000 chromosomes, one for each gene. So a lot of genes, like on the X chromosomes, are literally 200 genes. So they're linked on the X chromosome. And they're linked on autosomes as well. So if they're linked on the same chromosome, I drew one line and put both genes. Okay, that's called linkage. This means independent assortment. That means A is on a chromosome and B is on another chromosome.
Independent assortment.
Right. All these ratios here, all of those ratios, these dihybrid ratios, come from independently assorting genes. The genes are not linked. Okay, keep that in mind because all of this, I may not talk about a lot anymore, but we'll come back at it. So on your problems that you're supposed to do, turn in next week, you have to figure out the ratio. 9 to 7, 15 to 1, 9 to 6 to 1, but you have to know how to do that. And then you have to do a chi-square to show your hypothesis is correct.
And that's for the
Next week. You're supposed to bring that in next week.
Okay, is that it?
Yeah, that's it.
Okay. All right.
on the weekend.